Quote, "Our results show that automatically generated next step hints suggesting code changes can lead to higher correctness, faster progression, and reduce the number of help requests for the teacher. For teachers, this is ideal as it frees up their time to focus on learners who require the most assistance. Although a possible concern is that students may just implement the suggested changes without actually thinking about how this solves the problem. We observed no differences in comprehension." While these are encouraging findings, we also observe that hints generated for more complex code can be misleading, resulting in the opposite effects. End quote. That's from page 396 of the article titled Effects of Automated Feedback in Scratch Programming Tutorials, which was written by Florian Obermüller, Louisa Greifenstein, and Gordon Fraser. Apologies if I mispronounce your names. Here's the abstract for the paper. Quote, "Block-based programming languages like Scratch are commonly used to introduce young learners to programming. While coding, learners may encounter problems, which may require teachers to intervene. However, teachers may be overwhelmed with help requests in a classroom setting, and in independent learning scenarios, teachers may not be available at all. Automated tutoring systems aim to help by providing hints, but misleading or confusing hints can be detrimental. To better understand the effects of automatically generated hints, in this paper, we study a state-of-the-art hint generation system that provides suggestions when learners fail to complete a step in a programming tutorial. The system is evaluated using 2 cohorts of students aged 12 to 13, where one cohort receives only textual hints based on test failures, while the other additionally receives visual next step support in terms of illustrated code changes. We find that initially, the automatically generated visual next step hints increase the speed at which learners complete the steps of the tutorial and reduce the number of questions posed to teachers, without affecting the learners' overall understanding of their program negatively. However, with increasing complexity of the programs, the quality of the hints degrades, thus calling for further research on improving hint generation systems." End quote. If I were to summarize this paper into a single sentence, I'd say that this paper investigates the impact of 2 different types of hint generating approaches among 2 different classes. So in the introduction to this paper, the authors talk about how teachers can be overwhelmed, especially if they are new to CS and the students are also new to CS. Having done that before, it is sometimes difficult to get things started, but after like a couple of weeks or even a month, depending on how many times you're able to do it, students are actually able to sign into whatever platform they're using, and they're more comfortable using it without having a billion questions throughout each one of the classes. There are some steps that you can take to kind of set yourself up for success without having a hint generation system, but having a system like this might actually be able to help you out to make it so that you don't have to work with students one-on-one. But again, at the end of this episode, I'll talk about some approaches that I took without needing a hint generation system. The authors do note that hints can take many different forms in terms of like the kinds of approaches that you can use, and it talks about that in the review of literature, which is titled Section 2, Background. So in this, they talk about linters, tests, and next step hints as 3 different approaches. But I've mentioned in other episodes that there are some other approaches that you can use, even with the types of questions that you ask. Like you can have open questions, guiding questions, or even close-ended questions, or even analytical, judicial, creative, etc. I'll include a link in the show notes at jaredoleary.com to some other podcast episodes that talk about question techniques that you can use, because that is something that I am quite frankly a big fan of when it comes to education. Rather than telling somebody something, you can guide them through some questions to help them discover or uncover a solution to a problem, a bug, or whatever. So check out some of the other episodes that are linked in the show notes if you're interested in learning more about that. The third section of this paper just kind of talks about, well, what is the interactive tutorial system that they designed for Scratch? So if you want to learn more about that, check it out. But basically, in this particular study, they're going to talk about 2 different approaches. One is text-based, where kind of like explains step-by-step like what you could do for the next hint. And the other has like some pictures where it shows like instead of doing this, do this. And it shows like the different blocks that you might be able to use inside of Scratch. This particular paper was guided by 4 different research questions, and I'm going to kind of combine them into one longer one. So the questions were basically, how does the hint system impact motivation, progression, help requests, and comprehension? So those are the 4 main areas that we're going to explore in today's Unpacking Scholarship episode. And in this particular study, they looked at a boat race tutorial, and you can read more about that on page 398 if you're interested in learning about, well, what was it that students were actually creating through the particular tutorial that they were following. The authors note they were able to compare 2 different classes. So the teacher had mentioned that the students were about at the same level, and that one of the classes had 19 students, the other class had 22 students. So one of the classes was assigned to the textual only hint, and the other was assigned to the one that had the visually generated next step hints. So while the results from the study are not generalizable across like large populations of students, it is interesting to explore the idea of automated hint systems that you might be able to use in your classes. Like Khan Academy has some built into their JavaScript tutorials and whatnot. So this is not a brand new idea. This has been around for quite some time, and the authors do talk about this in the paper itself. But one thing I will caution is that every single class has a different vibe to them. So like when I first started teaching music, one of the schools that I was at, they would have like 3 third grade classes in a row, and then like 3 fourth grade classes in a row, and then 6th grade, etc. So it was just like back to back the same grade level. And it honestly made it easier for me to be able to teach because I didn't have to like rearrange the room and get out different stuff for different portions of the day. I could just leave things out for a couple classes in a row, switch over to the next one, etc., which was great. But what was even better is I was able to see just how distinctly different each one of those classes could be. It may have been the exact same lesson because I've talked about this before. They were mandated lessons and you get in trouble if you didn't teach the exact same lesson the same way on specific days. So that's a topic for a whole different podcast. But when you teach the same thing and see how it was received completely differently by the exact same age group, one right after the next, it really teaches you a lot about how distinctly different each one of the classes you work with can be. So I say all this to say that there are 2 distinct classes that are in here, and we cannot generalize the findings from this outside of those 2 unique classes. If it had been flipped so that the text-based group was now doing the visual one and vice versa, we may have gotten similar results. Or we may have gotten completely different results, and we don't really know that. But it is important to explore these kinds of questions and whatnot because we can learn through these explorations, which hopefully this podcast will help with that. On page 399, the authors start breaking down some of the results. So the first one is, how do next step hints influence motivation? This is research question 1, and here's a quote from page 399 that summarizes that. Quote, our study suggests that the next step hint tutorial system was well received and liked by the students and had a positive effect on the motivation of the students, end quote. If you want to see the general breakdown for this, you can find some figures on page 399. It was interesting to look at it. In general, the students tended to prefer the visual system more so than the text-based one. I do wonder out loud if that would have changed if this was like a text-based language, like if they were doing JavaScript or something. Would they have preferred to be able to read through the text rather than look at pictures of text? But I don't know. That's a whole separate study. This is me thinking out loud. I imagine this was helpful for some students who did not want to ask for help. I found that to be fairly common, especially as students got into like the late elementary and middle school ages. They didn't necessarily want to look, quote, dumb in front of their peers. So they would often not ask questions that were like good questions or share when they didn't understand something because they didn't want to embarrass themselves in front of their peers. But then if you go into like high school students or even like early elementary, they're generally speaking at an age where they're not as concerned with that. So I'm kind of curious, would this have like made a difference for like kindergartners versus like undergraduate students? But again, that's outside of the scope of this particular study. But that is something that is useful for educators to consider, is that every single age group is going to have some different tendencies in terms of where they might lean towards being comfortable with asking for help or not. And again, going back to like the class example, there were some classes where like there was a norm within it that the teacher made it very comfortable for people to share their misunderstandings or questions that they might have. And then there are other classes where it was much more competitive and they were not willing to share those kinds of things with students or their peers rather. So depending on what kind of class the homeroom teacher might have or the teachers that they see throughout the day, like if they're in like a middle school cycle where they have elective classes, etc., that might have an impact on whether or not students are willing or interested in asking for help in the classes that you facilitate. Might have nothing to do with you as an educator when you first start teaching with that group, but it might take months to actually develop the like trust that students are going to have in coming to you for asking for support and whatnot. So just be patient with it and consistent with just like letting students know that like, hey, I'm here to help you out. I'm not here to judge you. I'm still learning as a computer science educator about how to do this kind of stuff, so let's learn together. If that's the general vibe that you have, then it will pay off in the long run, at least in the experiences that I've had and a lot of the teachers that I've spoken with. Now, the next question is, how does next step hints influence progression? Here's a summary on page 400. Quote, our study suggests that next step hints generated at early stages are precise and helpful, leading to better performance, while hint generation is less reliable for more complex programs, negatively affecting performance, end quote. So what they basically found is that towards the beginning of the tutorials, the hint generation system was more useful for them and students were using it more, but as it got into the more complex stages of the tutorials, it was less helpful, especially when it would give like a false recommendation or whatever. So it might lead students down a path where it was actually giving bad information that was ultimately going to lead in students not being able to complete the project without a series of bugs or whatever. Now, one of the interesting things they did on page 400 is they talked about some of the less helpful hints that were provided. So one of them are the like starting block suggestions. Like, hey, in this next step, you're going to use a when sprite is clicked. For the students in this particular study, that wasn't as helpful as talking about what comes after that, which for me is interesting. Like, I think there should be different layers of types of hints. So when I'm providing a hint for a student, I might talk about, okay, well, what event do you think you're going to use to be able to do that thing that you want to do? And then they have like a list of events, and then they're going to kind of go through it and figure it out, but also guiding them through, okay, well, then what is going to happen? And then. One of the things you can do with like Scratch, because it's like set up into different types of blocks, like there's motion blocks, there's sound blocks, there's the events blocks, control blocks, etc., etc. If your students are having issues with it, you could start with, one, what kind of events are you going to use? And then after that, what type of block are you going to use next? Do you think you might use a motion block or a looks block? If they don't know, you can say, okay, well, what is it that you want the sprite to be able to do? Do you want it to be able to move around or change the way it appears or make a sound? And if they're like, I want it to make some kind of a sound. Then you go, it sounds like you might want to use one of the sounds blocks. Which one of these sounds blocks do you think you would use in this particular scenario? You can kind of guide them through these different layers of hints. So you don't have to just give them what are you going to do next and then just leave them, but actually like help them think through the different steps that they're going to do in the sequence without necessarily giving them an answer to that. Now, the next two main areas that the authors mentioned that were unhelpful hints were when like the block was wrong. So it gave you like a wrong direction to go down, or just give you like some unnecessary scripts where it's like you're going to use a go to XY block and then a go to X block. It's like, wait, that's like kind of doubling up. You're doing X, the same thing twice in a row. Like, why would you do that? So that would cause some confusion with students where they'd be like, wait, I thought this was doing one thing, but now it's telling me to do the same thing in a different way. But over time, I imagine these systems are going to get significantly better, especially when it comes to being able to help with more complex projects. So research question 3 is on how do next step hints influence help requests. Here's a summary on page 401. Quote, our study suggests that next step hints increase the interactions of learners with the tutorial systems while lowering the number of questions to the teacher significantly, end quote. Which that totally makes sense. Like if students are able to use self-guided resources and support systems without having to ask the teacher for help, that's going to make it so the teacher is receiving less requests, which will make teaching a lot easier because you're able to sit down with the students or the group of students who might need more assistance, and the ones who might have just like a minor question or kind of like get stuck with it, they don't have to wait for you to answer that. But again, at the end of this episode, I kind of talk about some approaches that you can use where you don't have to use this like next step automated system or AI or whatever to help you out with this kind of approach. And the last research question is on how do next step hints influence comprehension? And the authors mention, quote, our results suggest that comprehension is not significantly influenced by additional next step hints, end quote. So on page 401. Now, what I do wonder about this is how it would compare if it had a third group. So a control group where the students did not receive next step hints. Would the comprehension be the same? Would it be less? Would it be more? If the comprehension is the same, but it lowers the amount of work that the teacher has to do and it makes it so that the students are able to move at a faster pace because they get more in-the-moment feedback, then cool. This sounds like a helpful system for the most part, as long as it doesn't give some like wrong paths to head down or some redundant code, etc. And then finally, the paper ends with a discussion on some of the related work and then some conclusions. And you can check that out on page 401 if you're interested in that. Now, at the end of these Unpacking Scholarship episodes, I'd like to share some lingering questions and thoughts that I was thinking of when I read through this particular paper. So the first one is, what kind of projects can students create with such a tool? So if you compared over the course of a year, a class that used this kind of a tool, whether it's the text-based or the visual-based, versus a class that did not have this kind of a tool, what types of projects might come out of that? So one of the things that has been really interesting when listening to people at the Scratch Foundation talk about their workshops is they measure the success of the workshop by the diversity of the projects that come out of the workshop itself. That's one of the many things that they'll take a look at. And that is a fascinating way of looking at it, because going with like Mitch Resnick's discussion of projects, peers, passion, play, etc., which you can learn more about in episode 106, which is titled Lifelong Kindergarten with Mitch Resnick. It was a fantastic interview. But one of the goals of exploring passion, peers, play, projects, etc., is to get people to express themselves and explore their interests and create what they're interested in rather than recreating the exact same thing as all of their peers, etc. So for example, one of the options that students had was to be able to create stuff in Khan Academy. In Khan Academy, if you follow through this, you're going through the lessons, going through the scripts. By the end of each one of the little units, everybody creates basically the exact same project. The reason why is because of the hint generation system that they're using encourages students to be able to create the exact same thing because it has a very small range of acceptable answers within it to be able to move on to the next step. So everybody's going to create like a dog, or everybody's going to create a Pong game or whatever, compared to, hey, use these shapes to draw an animal, or hey, use these concepts and practices to create some kind of a game. Those are two very different approaches. So I'd imagine that two different classes that use two different approaches, one where it's more open-ended and the students can create what they want, and the other is where people are following stuff, they're likely going to create this exact same thing compared to the students who are going to create what is interesting to them. There's going to be more diverse projects that come out of that. That is much more culturally relevant and much more interest-driven than the other approach where it kind of treats everybody as the same and creating the exact same thing. It assumes a buy-in into that. This approach can work really well if people sign up for it. Like if it's an elective class where students are like, hey, I really want to learn computer science. Show me whatever you got. I'm in. I bought into this. I want to learn this thing. Compared to classes where the students are forced to attend, like the K-8 classes that I used to work with, you might have the best sequence of lessons for the students who are bought in, but the ones who are like, why do I need to learn this? They're going to be like, this is pointless. I'm not interested in making a game or a story or whatever. But if you gave them options of like creating a sports project or creating a racing game or whatever, then they might be like, yeah, I'm totally into that. But if that's not in your unit, well, they're going to be bored in your class. All that being said, there is a way to actually do rhizomatic learning with these kinds of tools if you have enough projects to select from. So for example, I previously created a bunch of curricular resources used by students around the world. Those curricular resources you could go through sequentially. Start with project 1, go to project 2, project 3, etc. Or you could say, here's a list of 3 different options. Pick which one of these 3 look interesting to you because they all explore the same concepts or practice in a different way. Or you could go a little bit further down the rhizomatic path and say, hey, here's 10 projects. Pick one of those 10 that look interesting to you. It might be a game, it might be a story, it might be whatever. Or completely rhizomatic where you could say, hey, pick any of these 40 projects or make up your own. We can storyboard it together and kind of figure it out. That approach could use some of these automated tools, but it will get to the point where if students are creating their own projects, they're going to get into some questions that any kind of like automated tool is likely not going to be able to help solve that. Which gets into my next question. How do you teach students to provide feedback to peers when other forms of feedback are unavailable? So each of the different approaches that were mentioned in this particular study could be done by yourself or by students with some kind of modification. And there's a ton of valuable lessons that can be learned when students are actually providing feedback to each other rather than relying on automated feedback. I don't know about for you, but for myself, I started teaching when I was in high school. And so I taught a middle school class with the first drum instructor that I ever had. And it was like a summer school class, and I realized that I needed to learn how to say things in many different ways in order to be able to help different students who had different issues with their drumming technique or whatever. By learning at something and like holding a concept as like a gem that you could look at from many different angles or many different facets and kind of explore it, it allowed me to better understand those concepts and practices. And the same thing can be done with computer science. So yeah, an automated system might be very helpful for like homeschool students or students who are working on their own at home. But if they are in a space where they have peers, I would argue that students can get more out of teaching each other. Not necessarily learning from their peers, but actually teaching their peers. So even though it might be better for the individual student to learn from an automated feedback system because it's much faster, they're able to get right into an answer and be able to move on with their next step, my guess is that students will learn more in the long run if they learn how to teach their peers. Which is why, like, when I was in the classroom and I was doing this rhizomatic approach where if there was like 30 kids in the class, they were working on 30 different projects with several different programming languages, etc., the students had 4 steps that they followed. So the first step was to check the built-in like manuals, the resources, etc. So like RTFM, so read the free manual will be the family-friendly way of phrasing that. The next 2 steps were to ask like their peers. And then the final step was to ask myself if I was not working with somebody. If I was working with somebody, you got to repeat the first 3 steps. This made it so students were helping each other out quite a bit. And if they happened to get to step 4 and I knew somebody else could answer that question, I'd be like, oh, Johnny, you have an issue with that bug? Well, Susie knows how to solve that. Susie, can you come over here and help Johnny out with this? Because again, Susie's going to learn a lot by exploring that concept and reinforcing when they are teaching Johnny the same thing that they had an issue with earlier. If, however, you're working on some kind of a curriculum where all the students are using a system that has like some kind of hint generation system or whatever in their classroom, cool. Nothing wrong with that. But you can still add in opportunities for creativity in that. So let's say you saw students 5 days a week. One of the things that you could do is days 1, 2, 3, and 4, like Monday through Thursday, you're going to have it so that students are following the pre-scripted lessons that like kind of have them all create the exact same thing. And then on Friday, they're going to go into a blank project where they are going to apply what they learned inside of that project in a way that's individually meaningful. You could also do this with units. So like in Khan Academy, it would have like a unit on how to draw shapes or something. Cool. Once you finish that unit, I would have students go into a blank project and now make something with those shapes. Could be architecture, it could be a face, an animal, whatever. Then maybe the next unit was, okay, now we're going to animate some of these shapes. Awesome. Now that you've learned animation and you finish that second unit, now go into your project that you worked on previously and add in some kind of animated shapes, movement, etc. That's how you can go through a pre-scripted sequence while also providing opportunities for culturally relevant, interest-driven learning within the same shared space. But another question that I have is, as teaching, assessment, feedback, etc. becomes more automated, how will this impact teaching and learning? If you think about it, this is the worst that AI will ever be. It's only going to get better. So what is the role of an educator if AI can provide faster and more accurate answers than like a novice computer science educator? Like when I first started, I often would get questions where I'm like, I don't know the answer to that. Let me look it up. I'll come back to you tomorrow and try and help you out with that. If students realize that their teacher is not as helpful as like an AI system, they're going to rely on that AI system more so than asking the teacher. So what is the role of the educator in that particular scenario? Is it going to get to a point where the teacher is just there to kind of like manage the classroom environment and not necessarily need to know the content area? I don't know. For now, being able to treat the student as a human with unique goals will help teachers to be able to distinguish themselves from AI and where it's going to be 5 and 10 years from now. But I would argue that if we focus on teaching to the group rather than teaching individuals within a group context, we will not provide an experience that is above what AI can provide. But I'm curious what you think. Do you agree? Do you disagree? Do you have other questions about AI or some papers you'd like me to explore? You can leave a comment on the YouTube video or on any of the other social media platforms linked on my website, jaredoleary.com. Just let me know. And if you enjoyed this particular episode or any of the almost 200 episodes, please consider sharing it with somebody else. It just helps more people find the free resources on my website at jaredoleary.com. I've been adding a bunch of Scratch tips and whatnot over the past month, and there's plenty more that's going to come. And there's also a bunch of content around drumming and gaming. Like there's over 1,600 hours of drumming content. So if you're into that, check it out. Odds are you're going to find something that will challenge you in a fun way. But anyways, thank you so much for listening. Stay tuned for an episode next week, which will also be on Scratch. And it's going to talk about Scratch in physical education, which was an interesting paper to read. Until then, I hope you're all staying safe and are having a wonderful week.